going to get started. Since my introduction is relatively brief and kind of give the same introduction every time we do one of these things. And that'll give an opportunity for people to keep rolling in while we get ready for Erica and Yelda's presentations. So welcome to everybody who is here as of yet. I think I know almost everyone here, so I'll keep it nice and brief. For those of you who aren't familiar with who I am or what we're doing, my name is Evan Schmidt. I'm the outreach coordinator for TallWood Design Institute. And this event today represents one of a number of basically research presentations in our so-called research brief series. So typically we do an annual event where we share research from various faculty who are doing mass timber research or are affiliated with TDI. And this year we've gone all virtual. So today we will be hearing from Dr. Erica Fischer and Dr. Yelda Turkan, both at the School of Civil and Construction Engineering at Oregon State University, and we'll be talking about fire engineering. So with no further ado, I'm just going to hand it off to you, Erica, and you can start. As always, if you have questions, please put them in the chat, or preferably just save them for the end of both presentations and just ask either Erica or Yelda directly. So.
Oops, I have multiple things open. Can you see it now?
Yeah.
Okay. All right, great. All right, thanks everyone. Thanks Evan. So yeah, as he mentioned, I'm an assistant professor like Erica in the School of Civil and Construction Engineering. My background is not in fire engineering at all. I am in the coming back with my background is in geomatics, remote sensing, and construction engineering management. And this is actually on this project I'm collaborating with Erica. And it is funded by TallWood Design Institute, and we're studying how we can use building information models and fire simulation models to show the sequencing in construction sequencing of fire protection in mass timber buildings. So as we all know, mass timber buildings are vulnerable to fire, and that can cause significant losses, both financial and through the loss of lives. And in particular, mass timber buildings that are under construction are largely unprotected since they are not yet equipped with active fire protection systems. And there hasn't been a lot of research they're demonstrating the construction sequencing results to optimize the safety, property loss, and the cost of these fires. So in construction engineering and management, we use, you may be familiar with prevention through design concept. So in order to enhance safety awareness and understanding of fire safety risk and its consequences, we need to have an effective fire safety planning to eliminate or significantly reduce the fire hazard impacts on a given job site. There are traditional fire safety planning that relies heavily on frequent manual observations on the site. That can be labor intensive, time consuming, thus ineffective, or not as effective. Fire safety knowledge is not very easy to transfer through the fire safety regulations alone. So the prevention through design concept tend to be a very effective concept to eliminate the fire safety hazards. And because it considers the fire safety during planning and design phases. So we figured that there's a research need, and our goal is to provide designers a prevention through design tool to assess the construction fire risks during the early phases of mass timber buildings that are under construction at an activity level and daily activity level. I mean, if you're not familiar with construction project schedules. There are different activities in construction. There's the master schedule and the daily schedules that the foreman uses. So our goal is to provide this PDT tool at the daily activity level. And the benefits of using computational tools in the construction industry has already been proven, such as fire dynamic simulators, agent-based modeling. They're proven to be effective in our previous research and by other researchers. In building information modeling, as you know, it has been very popular in building industry. Now it is in the infrastructure industry. It has been also used along with other technologies. So in this research, we're going to use building information model for fire safety throughout the project life cycle. In the previous studies, researchers identify several obstacles when trying to combine BIM with fire dynamic simulation tools, software that are available in the market, including data interoperability and as well as other technical limitations. So in other words, you cannot simultaneously model the fire dynamics and the agent-based modeling, in other words, the evacuation process. So I guess I've already kind of covered the goal of our project that is just starting this winter term is to develop a solution in the implementation of prevention through design to assist designers and builders to assess construction fire safety risks, and develop an analytical framework to couple the commonly used computational tools such as FDS that can be implemented in the industry. And we're going to do this by applying other advanced computational modeling concepts together with four-dimensional BIM. Four-dimensional BIM is the building information models plus the project schedule for fire risk assessment and control. Here's a brief view of our methodology. As you see, we are you may or may not be familiar with the level of details of BIMs. There's the AIA standards for building information model level of details. So in this research, we will be using LOD 300. That corresponds to the building information model level of detail at like as built level of detail or construction level of detail. So we will be using that along with agent-based modeling software, Pathfinder. This implements C++ coding and we will also use PyroSim for the fire dynamic simulator. So we will either develop a building information model or if it is available, we will use that available building information model in Revit, and we'll couple that with the project schedule to create a four-dimensional building information model. And this will be in IFC format. If you're not familiar with IFC, it stands for Industry Foundation Classes. It's a neutral file format. So it is interoperable with other software. That's why we're going to use that. How we're gonna get into this? We've done similar work in the past. We tested a similar fire simulation framework for a timber structure. In the simulation, we created a building. This is actually a case study of the night fire that happened in 2003 in Rhode Island. So we got the drawings of that nightclub, and we created a building information model, and we also got the case, the report, incident report. Based on that, we created a fire dynamic simulation, and based on the number of people that were there on that night when the accident happened, we created a agent-based simulation to optimize the design. So we were trying to see how many agents can evacuate on time and efficiently. So it is, as you see here, the agents are randomly distributed, and then when the fire starts, they tend to run toward the main entrance, and and then they block the main entrance. So there are a lot of factors that needs to be considered. So our goal was to, in this one, our goal was to find the optimal design and number of exits for that building. And here's a very can you still see my screen? There's a very short video here that I wanted to show. It just basically, it's the visualization. We just made a very short video from the building. That's the, I'm just gonna, you can see the smoke progressing. And then the visibility changes with that. I'm just gonna fast forward this. This one shows smoke view. This came from the fire dynamics simulator, and then later on we looked at the agent-based modeling and looked at different design options to find optimal design. So yeah, this is something that worked for. So for this one, we did use three-dimensional building information model. So we're essentially just going to be using the same framework for construction sites. Sorry, I'm just trying to get back to my slides. Okay, and then we've done similar, and then we also did the construction sequencing. This is another, so we were linking, this is, as you see, the construction schedule that is divided into structural, architectural. It is not at the daily, you can't see the daily details here, but we use the SynchroPro software here. It's basically showing the four-dimensional view, right? The combination of the 3D and the project schedule. And there's a very short video here for that too. Just you may or may not be familiar with this, but you can see the schedule and how the project progresses. So in this new project, we are going to have such detail that we can see the fire protection install, when they're going to be installed, so we can the designers can easily see how the construction is going to progress, and when those fire protection systems needs to be there, and they can simultaneously visualize the fire, if there was a fire, how they can effectively visualize the evacuation and fire progress. Sorry about this. Again, I'm trying to get back to my slides. And now I don't see my, okay. All right, back to this. That was the last video. So with that, we already started the literature review. We are focusing on the modeling rate of the fire spread on the surface of mass timber, and the influence of exposed surfaces of mass timber on the fire dynamics, and inclusion of wind into fire behavior modeling. As part of this, we are going to speak with building officials and contractors to listen to the challenges they have, in their needs. So we will also look into the using the international building codes in this. And then we will be developing the methodology in the framework. We will develop acceptance criteria and measurement categories for the simulation. This will be done through discussions with contractors and building officials. We will develop acceptance criteria and determine the measurable methods to examine the impact of the construction sequencing of fire protection on the safety of the building. And so that the simulation outputs are expected to provide the information that is needed for the fire risk assessment, so that the workers can egress safely and the property loss and other things can be determined. And we were actually in touch with a company, Sivinerton, to conduct they agreed to give us data for a case study of a building, mass timber building, its Revit model and the construction schedule. So we will start working on that soon, and we will be given as we have more results, we will be given more webinars and publish our results. Again, the anticipated outcomes were hoping to, at the end of the project, hoping to have an innovative prevention through design tools targeting mass timber building designers and contractors as primary end users to assess and mitigate construction fire risks, and a practical analytical framework that can be used by the industry to assess, to conduct risk assessments and select design and construction sequencing alternatives concerning fire safety, and a simulation solution that associates the advanced computational concepts along with four-dimensional building information models. And the components of this study will, we hope that it will promote the awareness of construction fire safety, demonstrate the feasibility, and identify gaps in knowledge and fire dynamics modeling, and provide an innovative prevention through design tool targeting timber building designers and contractors, and benefits in identifying and mitigating construction safety, construction fire risks, and provide safer workplaces to their employees, and we will hope to promote the use of mass timber in buildings throughout the US. And that's all I had. Thank you. I'll stop sharing.
Thank you, Yelda. Yeah, so if you have any questions for Yelda, again, you can feel free to put them directly in the chat, or you can save them for the end and you can ask her directly. Erica, are you there? Do you want to try sharing your screen? If not, I have your presentation downloaded so I can try. Okay, we're seeing it this time.
Do you still see the screen?
Yeah, I see it. It's not in presentation mode on my end. I don't know if anybody else is seeing anything different. Are you in presentation mode right now, Erica?
No, I'm trying to turn off. Oh, here we go. Okay. All right. Do you see are we good to go?
It's still in its like kind of standard PowerPoint mode, but you could try, like mine is frozen on your like intro screen. So if anybody else sees anything different, let me know. But
Okay, I don't really know.
Hey, Evan. It's
Uh-huh.
it's Judith. Maybe while we're sorting that out, there were a couple of questions in the chat for Yelda.
Yeah, that's a good idea. And Erica, I can try sharing my screen. So you can
Okay.
sharing and seeing if you can work that out. And if we get through these questions, then we can try again. So yeah, the first was from Robert Gerard, and Yelda, his question is, has there been any engagement or feedback from insurance companies as to the fire risk assessment during construction?
Thanks, Evan. Yeah, I was just trying to write back, but yeah, that's a very great point, Robert. We have not been talking to any insurance companies, but that's really that's something to consider for the future. And then I see a second question. Yeah, I meant light frame timber buildings.
So you meant, so the question from Eric McDonald, Eric asked, for example, construction fires and mass timber buildings with loss of life. And he asked if you just meant light frame, and Yelda, you said yes, light frame.
Mm-hmm.
Okay. Erica, do you want me to try sharing my screen?
Yeah, why don't we just do that? This is getting a little ridiculous.
Okay. Yeah, here, let me give that a shot. Let me know if you can see it properly here. You guys seeing that?
Yep.
Okay. So you just say next slide, and I'll follow.
All right. All right. So I'm going to talk about a few projects that I'm working on collaboratively with professors both in civil and construction and in the College of Forestry and at UO Architecture. You can go to the next slide. Just go to the third slide. We'll just jump ahead so you don't have to keep pressing. So there's multiple ways that you can approach, as I was saying before, fire protective design. You all are very familiar with the prescriptive approach. You can just jump ahead 2 slides, Evan. So the current, back 1. Thanks. So, our current fire protective design strategies are, the prescriptive approach. That's the hourly rating that you're all very used to. That's what the IBC 2021 is going to have massive changes to for mass timber construction. When we talk about structural fire engineering, though, we are talking about the capacity of the structure to maintain stability throughout a complete burnout fire. So that is not looking at hourly ratings. It's looking at the fire science within the building. It's actually calculating what the fire would be in the building and looking at how the fire would spread in that building, and then looking at the structural behavior in response to that fire. So it's based on testing data and empirical data. Go to the next slide. So when we talk about the prescriptive approach, and I know I mentioned this all in my last presentation with TDI, but I'll mention it again. We're talking about an ASTM 119 exposure. That's the fire on the right that I'm showing. That is not related to a building in particular. So that's just one fire exposure for all buildings. You can think of it as one ground motion for all building designs. So a bit unrealistic, but it works, and it's conservative in some cases. The ASTM E119 failure is not related to the structural performance for walls and for floors. For mass timber, it's related to flame through, so preventing fire from spreading from one floor to the next. And so that hourly rating that you're getting from the International Building Code is not particularly related to the structural behavior. So when you have a floor with a 2-hour fire resistance rating, that doesn't mean the floor is going to collapse in 2 hours. It just means that after 2 hours, that assembly met the ASTM E119 failure criteria when it was exposed to the fire that I'm showing on the right. So next slide. So when we're talking about structural fire engineering, we're really talking about, well, what could possibly be the fire in this space? And then what's the behavior of the structure in response to that fire. So we're not talking about hourly ratings, we're talking about structural capacity. So, this is more where structural engineers feel more comfortable talking about plastic deformations or deflections or failure. Next slide. So I'm going to talk about a number of ongoing research projects, and they all really fall under these 4 goals. So I'm going to really kind of repeat myself throughout, and really it's because using this kind of framework, like we're able to employ structural fire engineering on mass timber buildings, just as we can do on steel and concrete buildings. And then we can demonstrate structural behavior and performance in fires that are specific to the building. And so really this revolves around generating useful testing data. So, what can we actually physically test that generates data for engineering, architecture, and construction industry? And then using that data to benchmark our numerical models, whether they're fancy finite element models or just empirical models that have been previously developed and that you can all use in a spreadsheet or something. And then working collaboratively with all of you to actually be able to test things that are useful for industry. And understand what those gaps in knowledge are, what's preventing you from actually employing this on a building, and what's preventing jurisdictions from accepting it. And then I would say most importantly, we need to train and educate the next generation of our mass timber designers. So, we'll work with you collaboratively and give presentations like this to get our research data out into industry so you can use our research data, but more importantly, so that you can hire our students that we've trained and you can have those experts in-house. And so these are some of the firms that and collaborative partnerships that we've built throughout the last 3 years working on these fire projects. Next slide. So these are 5 ongoing projects. I am not going to talk about all of these. Yelda already talked about the modeling for fire safety and construction sites, and I'm going to highlight a few others that are ongoing. The next slide. So this project I've talked about quite a bit over the last years. It's surprisingly still ongoing. It's been delayed due to COVID, but that allows us to kind of explore some new opportunities. So we've been looking at the fire performance of timber concrete composite floors over the last 2 years. This project is a collaboration with Andre Barbosa and Arjit Sinha. And there have been 2 students that have worked on this. Annabelle Shepard just recently graduated. So she is in Portland working for PCS Structural Solutions and doing amazing things. Here are a bunch of conference papers coming out later this year, and a journal paper hopefully coming out later this year. But what was the problem we were trying to solve? So we saw that over and over again, timber concrete composite floors are being used in buildings, but the building jurisdictions are really asking the engineers to ignore the concrete when they look at the fire rating or fire behavior of the structure. And so, no, you can do it. Keep going. Great, thank you. So we said, well, we need to generate some testing data. We need to generate some data on these floor systems and these floors that are actually being used. So we kind of pulled from work that Dr. Barbosa and Dr. Higgins have been working on the CLT floors with the self-tapping screws. We built off of some work that's been ongoing at FP Innovations to test some commonly used assemblies. we use the data from that to demonstrate that empirical models can actually be used to predict the capacity, the strength capacity of these floors throughout a fire, and also the deflection. And then we actually took those models and we applied them to other tests that have been done besides ours, and we showed that they work there too. And our goal is then to also perform a parametric study in our finite element model. Next slide. So what's in gray has been completed. What's in black has not totally been completed yet. But like I said, we've benchmarked our data against our models against the data, both our finite element models and our empirical models. So we're able to actually simulate heat transfer through the floors. We're actually able to use just Excel spreadsheets to calculate the strength and deflection throughout the fire. We're able to use our finite element models to calculate the ambient loading behavior. We're coupling our finite element models together, and then hopefully in 2021, we'll have round 2 of testing. This has been significantly delayed as we test in Canada, and everyone was shut down for COVID. Next slide. So this, the next project I'll talk about is the fire and seismic performance of glue laminated beam to column connections. This project is in collaboration with Arijit Sinha and College of Forestry. Haley Madeline is the master's student working on this project. And I don't think I need to tell all of you that there is hardly any data on gravity beam to column connections in under drift compatibility and in fire. And there are a lot of stipulations in the code limiting these connections, and hardly any of those limitations have actually been tested. So that is what we are hoping to do, is to test, notch depths that don't adhere to NDS, and to actually look at that, temperature stipulation in that International Building Code for the temperature of the steel elements when they're embedded or concealed in the timber. Next slide. So how are we going to do that? Well, we really want to generate testing data on non-proprietary connections. There's definitely a lot of proprietary connections out there, but if we can test non-proprietary connections that provides data that's really useful to all of you that are here today. We want to compare the calculated capacities with our experimentally measured capacities. So how do we actually design these connections, and how do they actually perform? Demonstrate ductility, and then also compare the fire testing to the code prescribed temperature limitations. Next slide. So in 3 weeks, we will be building these connections at Oregon State University and hoping to test in after the new year. And the test connection, and then we'll be testing the connections at the NRC under fire next fall. Next slide. So we are testing all bearing connections that are concealed connections, non-proprietary. We're going to be looking at the limitations of the code. And one thing that we are actually doing that we are very excited about is we are working collaboratively with the Pacific Northwest Carpenters Institute. So the last time I presented on this through TDI, there was a great suggestion made that we need to train skilled laborers in how to actually build these types of buildings. So this collaboration has been very exciting, and so we are going to provide a space for skilled laborers to learn how to work with CLT and glulam and actually build these connections. So it's exciting for us to work with the Pacific Northwest Carpenters Institute, and I am looking forward for Haley, the student, to interface with construction workers and answer all of their questions, and then vice versa for them to work with us and kind of get that experience interfacing with engineers. Next slide. Okay, so the most recent project that we're working on, and I had a call about this earlier today, is looking at fire testing in tall timber buildings. So there is a huge dichotomy in what is actually being built and what is being tested when we look at our large scale fire tests. When we look at what's being built, I mean, I don't really need to tell all of you, you're the ones designing and building this. We're looking at these large open compartments. But what's being tested are small compartments, and so that is not as big of a deal when we're talking about non-combustible material. But when we're looking at the large timber compartments, there are so many questions we have with regards to the fire dynamics. This project is in collaboration with David Barber at Arup, Gavin Horn at UL Underwriters Laboratory, John Rawell, who's a professor at UO Architecture School, and also owns his own architecture company in Eugene, and Shilin Pei at Colorado School of Mines. Next slide. So, what are the biggest gaps in knowledge? We want to understand what is the fire dynamics within these large compartments? When we test our component level beam to column connections that I showed in the previous project, how does that translate to a actual large compartment system level test? Are these things compatible with one another? Looking at firefighter safety, what information can we provide to firefighters? How do we design these buildings for the decay phase of the fire so firefighters can go into these buildings and safely assess what is left? And then the project also includes a simulation portion. So being sure that we can actually simulate the behavior and the structural response of a building to fire. So again, coupling that data collected with an experiment to the simulation of the building. Next slide. So I just wanted to kind of put this up here again, talking about, we really definitely need to generate useful testing data for all of you to design and more efficiently design your buildings and fill those gaps in knowledge. But that testing data can be used to benchmark and further develop numerical models that will allow us to test and kind of explore all these different parameters within the design space. We love working collaboratively with all of you to make sure that we're providing that pipeline of research, making sure that we're testing and looking at actual gaps in knowledge. And then, another pipeline that we really do need to acknowledge is the pipeline from academia into industry and training and educating our next generation of mass timber experts. And the next slide is just a summary of the projects again, and I'm happy to answer any questions.
Awesome, Erica and Yelda. Yeah, so we have plenty of time for questions. I haven't had a chance to look at the chat box here, so I don't know if anything has been posed. But if you have any thoughts or questions, please feel free to voice them directly here. So I'll open up the floor.
Hi, Erica. This is Hans-Erik Baumgren. How are you?
Good. How are you?
Cool. Good. I'm working from home these days. Are you?
Yeah.
The fun thing with mass timber is your projects get kind of funded and started in 6 months of time, where you maybe get to a point to do your tests. The industry or the markets have also shifted, right? So in that fire, up to 2-hour fire connection of exposed wood and connections is a really, I agree, and I'm happy to hear you're advancing your research project on that. Our company, other builders, other manufacturers in the last 4 months have all literally jumped through the fire hoop to get up to 2-hour ratings on connections. And I've rallied with a few of those people to share stories about where we think there are some unknown unknowns and really a need to work on those. They're you know, up to 2 hours. Any product up to 2 hours testing in timber has scant data, and that's been proven to be true here for a few of us. So I hope you're getting some input from those of us who have been there and failed and then passed on these tests. So I don't know. So I'm excited to hear this, because you can bring sort of something that's off a project track where we're on the clock to make a test work to stay in phase with a project being built. But you know, out of that, I personally, and I've talked to a few others, have some questions about what's really happening at elevated temperatures in some of these connections. So I guess it's more of an open invitation. Otherwise, we get way too far into the weeds. But the question would be like visibility on the connections you're testing. Are they buildable, constructible, inspectable? If there are products in there that are sealants or fire caulking, are they durable during wetting, during construction? We've thought through a lot of things like this that are important. The whole thing has to work, not just the fire performance.
Yeah, I agree. And that's really why we're testing under drift compatibility and fire, so that we have a demonstration of performance and we have data on the performance for both. We're in the Pacific Northwest, we're on the West Coast, we're in a high seismic region. We need to make sure that that's a possibility. You know, the Pacific Northwest Carpenters Institute is building these for us. And we do have a short survey asking them about constructability. And so that is something that we're looking forward to hearing back from, is how constructible they thought these connections were.
No. And I can understand, yeah, both are key. That's good to hear as well. I guess some people who really ask the questions beyond what the code would say today would be, are you looking at damage states after drift and then a fire event? That would be maybe beyond the scope of what the IBC requires, right?
Yeah, we are not looking at post-earthquake performance. But if we have, I mean, again, if we have the data on the seismic performance of these connections, we have the data on the fire performance of these connections. This is where numerical modeling can come in and be really useful for us as we try to test different configurations and post-earthquake fire scenarios.
No. Cool, thank you.
Yeah, thank you. There is a question on how are you determining the loading on the connections? Are you not using, assume you are not using any proprietary hardware. We are not using any proprietary hardware in these connections. I'm not really sure what you mean by loading. Do you mean for drift or for fire?
Yeah, this is Dean from Swinnerton. Can you hear me okay?
Yeah.
Yeah, sorry about that. I was a little bit ambiguous. The loading I was thinking about is just the gravity loading that is being put on that connection, and what size of member is being used. And looking at some of these taller timber buildings, it is kind of interesting because residential, you might get smaller members with smaller loading, or you thinking more office and you'll have larger spans, larger members, deeper beams that are going to be more critical for P delta effects. Wondering if that's been talked about at all, or what direction it's going.
Yeah, it's a great question. Thank you. We have, so this project, our industry kind of partners on this. We've been working a lot with Homes, so with Eric McDonald at Homes. And I've been talking with Graham Montgomery quite a bit at Swinnerton about the connections. We are using, realistic span lengths. We're looking at like a 28-foot span of a beam. We're looking at office occupancy, looking at like kind of heavy loading on the connection. So it's not like a low-rise building, one or maybe low-rise building, like 1 to 2 story building. We're looking more at like a mid-rise office building that these connections would be in. Happy to like share. I can like send you exact
Awesome.
numbers on everything. That's yeah.
That's awesome. That's good. It's great.
Yeah, thank you.
Had one for you, Yelda. So there are these rules specify that mass timbers need to be covered during construction. And many think that this might be a little conservative. So I'm wondering if, and I know you spoke to this a little bit, but I'm wondering if these tools that you're talking about developing, do they specifically represent an opportunity to kind of supersede these requirements using these tools? Like, is this something you could use as a contractor to say, we don't need to necessarily follow these guidelines for how we're covering the timbers during construction? Or do these tools and this research provide an opportunity to change the code altogether in terms of rules for covering the timbers?
That's a good question, Evan. Erica, feel free to jump in. By no means, I'm not a fire engineer, but so not the requirements, but we are trying to visualize it by using these tools because it's a 4-dimensional animate. We are going to be doing four-dimensional simulation so that the designers can actually see the construction sequence and when those fire protection is going to be applied at a given time, so that they can optimize. They can see if, let's say, on the at the end of month 2, the construction site is going to look like that. We can visualize that and see where the fire protection is, and then we can then do a fire dynamic simulation and then develop a animation that can show how workers can evacuate the construction site safely. Does that make sense? Erica, did you want to add anything to that?
Yeah, I just would add that there are the stipulations about how many floors could be unprotected on a construction site at any one time. And those stipulations are not necessarily based on research. It's so starting that process of researching what is the how many floors should be left unprotected. If that's it's why Yelda said talking to building code officials. If a company wanted to demonstrate that they could leave less floors unprotected at any given time, or more floors unprotected at any given time, providing kind of science-backed evidence as to how they could show that. And I think what Yelda has been doing with construction site safety and evacuation can show what other stipulations should maybe be in place to make sure that site is safe. So that was really the motivation for the project, are those stipulations and the lack of kind of engineering research on those.
Thank you.
Yeah, thanks, Erica.
And I guess as a quick follow-up, I just want to make sure I have it right. So is the tools that you guys are talking about developing, is it sort of like a plugin that automatically syncs with data from a Revit model so that a designer or contractor can sort of use that in tandem with what they already have on a daily basis to kind of assess the current status of their structure?
Yes, exactly. It's an API. It's like a plugin that they can use along with their Revit model and the other tools that they're fire dynamic simulation. Those are commercially available tools that they can use it. together with those tools that what we are developing.
Thanks.
Sorry, this is Robert. I might bring up the insurance question again. I think it probably goes to both of the presentations for Erica and Yelda. This is something I've spent a lot of time on, for better or worse, that of course, probably the higher priority stakeholders are going to be around the approval authorities, but we've ran into a number of issues with insurance, particularly in the area of construction fire safety, due to the perceived risk of exposed mass timber. I'm intentionally saying perceived for mass timber relative to light frame, because I think that given all of us on the call, we could probably safely say the performance is a little bit different than the risk for light frame construction, but I could see them as integral partners in this process in order to give them an opportunity to express their concerns and perhaps look at these as specific scenarios as part of that modeling, as part of the documentation process, to make sure that they're able to be educated and help contractors and developers in particular to have more realistic premiums associated with this construction. So that's, I guess, part of the question is maybe this could be something valuable. And my feeling is that someone like OSU would be in a great position to do so, given it's kind of a neutral third party relative to some of the other organizations we're involved with.
Yeah, thanks, Robert.
I also think, well, I actually know that they fund a lot of FPRF and some of the other organizations, so they do have a financial interest in this as well. So I think that could be another avenue there.
Hey, Erica, this is Todd. Hello, friends. So I had in your models, in your parametric models, are you trying to build in specific gravity? And then follow up is, can we come up with a small scale lab test where we can quickly characterize, the beam to column and then wall to plate, wall to floor, sort of characterize that and build that into your models? I know there are a lot of people that say it doesn't matter. I don't know if I buy it, but I'm outside my expertise beyond the images I showed you of my my fire testing. Inside joke, sorry.
So am I building in specific gravity? Like, am I looking at varying specific gravity of timber in the parametric models that I'm looking at?
Yeah.
Clear for this? In the empirical model that we did, we did not, but that can be, yeah, we did not look at that varying specific gravity. I think all the timber we looked at was the same. Although we did look at, CLT and NLT. And for our finite element model, we are able to look at varying types of timber. So right now we're coupling the thermal structural model together for the timber concrete composite floors. We can do it for pure timber. And we're able to look at varying types of timber. Just modeling the timber concrete composite floors is a little challenging, modeling the shear connectors. So I guess short answer is yes, in the finite element model. For the small scale tests for the beam to column connections, what I've seen, yeah, they all, I guess the fire tests that we've seen so far, a lot of them are lap splice joints tested in tension, which, it's helpful for like the general body of knowledge, but hasn't been for for the like connection assembly. We're not going to be doing, you know, like full column height, full, you know, like, or half span in a furnace. We're planning on doing some smaller scale tests in a furnace, to use the smaller furnace at the NRC. But our drip tests are large scale. I don't know if that answers your
No, it's great. I think it's just an open question to everyone. You know, we're doing some of these tests in the US are on Doug fir, right? High specific gravity. And then a lot of the European beam notch panel analysis and testing is obviously on Euro spruce. And so I'm just
Yeah.
worried we're going to go high end in the US and then not be relevant to low end.
Yeah, all of our floor tests were spruce, pine, fir. We didn't do Doug fir LT. So and then we used SPF for our NLT as well. And yeah, we're not testing. I haven't tested anything on Doug fir. Yeah.
Great, thank you.
Yeah.
Okay, well, maybe we can take one more question. It's now 5 o'clock, so I want to make sure our presenters can go get some dinner or whatever they need to do. But if you have a burning question you can't live without asking, this is your opportunity. I know that's a lot of buildup, so it's a lot of pressure. Okay, well, let's call it then. Erica, Yelda, thank you so much for taking the time to join us and talk about your research. I'm sure if any of you guys have a burning question, Erica or Yelda would be happy to answer it by email or something. So please feel free to reach out. And with that, I invite you to join us next week. I'll be posting our meetup probably tomorrow. And I implore you to have a good night, and we'll leave it at that. So thank you, Erica. Thank you, Yelda.
Thank you, Evan.
Good
Thank
job.
you.
Thank you.
Thanks, Evan.
All right. Have a good night, everybody.